Okay, so thank you everyone for joining DevOps Days and also this talk. And the topic of this talk is auto remediation, a journey towards self-healing infrastructure. So before I start on my presentation, I would like to give you guys a small introduction of myself. So my name is Arun Kumar Singh, and I work in Adobe as a site reliability engineer. So I've been with Adobe close to 4 years, and I work on a product on digital experience, and also parallelly I'm working on an initiative to provide auto remediation as a service to other teams. And moving forward, yep. So this is first of all, this is a story of evolution. So why evolution? It's because we started with something initially, resolving some small problems, small issues, and later on we find out that we need to go forward. We need to think of something different. We can resolve some problems which are not resolved by only one command. It could be a workflow, it could be something else. So we switched our architecture, we switched our technologies, and like this in the journey we evolved with different technologies. So how SRE thinks? So SRE is site reliability engineer, and how SRE thinks is first of all, it's like in one product, at least in Adobe, there are around 30 to 40,000 servers. And what we used to think is if we get one alert in 1 week from one server, which is not very realistic, there are more than that, then also we'll have 30,000 alerts to handle in 1 week, which is a huge amount. And I mean, if you guys were in the first presentation, so people were the PJ was talking about few things, mental pressure, so sites and these kind of things. So yeah, this is the solution for that. Second is we used to think that why we are doing the same thing again and again on multiple servers. So let's say if you have a disk space alert, so it's the very smallest problem that every server has one day or another. Then you clean up disk space, you clean some logs, you might change some configurations in log rotation. But this is the same task that you are doing on different servers. Maybe the name of the log file will change, some parameters in log rotation will change, but you are doing the same thing again and again on different servers. Third is on call. I guess most of you guys have been to on call, and you know how problematic it could be, especially when it's in the night. So nobody wants to wake up in the night in 2 a.m. or 3 a.m. and resolve a problem. So yeah, so I used to just a second. Yeah, so I used to think a lot that whenever I have to be on call in the night, then it would be a better thing if I had a bot or some workflow which is running in the backend and resolving some basic problems, some small problems while I am sleeping. And if there is any low priority ticket that comes in the night, then it collects all the diagnostic data and put it in a ticket for me, so that when I wake up, I get all the diagnostic data, and what I have to do is just resolve the problem after going through the diagnostic data. So problem statement. First and foremost, the sleepless nights, which I guess everyone in DevOps or SRE field hates. Second is human error. So we all are human, and we do mistakes sometimes. I mean, I have done in my career, I mean, running some commands in some other data center in the night where I have to run on some other data center. So yeah, productivity downgrade. So why productivity downgrade? For an example, if you get a call in the late night saying that this is an issue, so you spend a lot of time to actually resolve the problem. The lot of time that I am saying is you wake up, you take 2 minutes to say some abusive words to your company, why I'm in this company and I'm getting call in the late night, and after that, you spend 2 more minutes rubbing your eyes so that you wake up to do some action on production environment. After that, you join VPN or you SSH to server So this whole process takes around 4 to 5 minutes. But if you have automation running in the backend, that time could be resolved to less than 10 seconds. So that's where productivity downgrade is. Alert fatigue, as I have mentioned in the previous slide, if you have lots of servers, you have lots of alerts. So simply 30,000 servers, 30,000 alerts. So it's a lots of alert to be managed by one person. Last is runbooks. My personal view on runbooks and documentation is I love to read documentation, but I literally hate to write them. I guess how many people have mutual feelings with me? Yeah, so like-minded people, good. So moving forward, so I've been saying auto remediation again and again. So I'll just explain what auto remediation is. So auto remediation or self-healing, it's a workflow which actually triggers whenever there is a problem on your server, and it responds to that problem with one action or a set of action that you can call a workflow, and eventually resolve the problem without any human intervention. If we go with the simplest example of that, I have put a very simple example to restart a service. So it's a golden rule in DevOps and SRE that if you restart something, it will work eventually. So yeah, so this is the least and the basic one. So general auto remediation workflow. So this image is copied from some of the blog, I guess, from OpenStack or Netflix. So whenever there is an alert triggers, so if you have auto remediation, then you must have written some rules which will match and find out that is there an auto remediation for this problem? If yes, then auto remediation get triggers and the problem is resolved, we are good to go. If not, then only it will go to PagerDuty or any other escalation tool that you guys might be using, and collecting some diagnostic data and putting them together in a ticket and send it to engineering for acknowledge and troubleshoot the problem. So this is the very basic auto remediation workflow. Okay, so before I go to this slide, I just want to know how many of you guys know SaltStack or have worked on it? Okay, few of them. How about Rundeck? Okay, few of them. And how about StackStorm? Okay, only one. Okay, this would be very informative then. So our journey started with SaltStack. Because in Adobe, every team is using SaltStack. We call it as a standardized service for configuration management. So every team is using that. So we wanted to pick up something that every team is already using and already aware of, so that we can reduce the learning curve. So we started with the SaltStack, and we were good for some time. We were good to resolve some of the problems, but as I've said, it's a story of evolution. So we find some problems with it later on. We were not able to resolve some kind of workflows that we wanted to resolve. So we changed and moved forward to Rundeck. And with Rundeck as well, we were happy. We were happy for some time. We spent some time, we created a different architecture. The load that we sent to Rundeck, he was able to handle it very properly. But again, there was some problems with Rundeck as well, which I will tell you in moving forward in next slides. So then we moved to StackStorm, and we are right now we are on StackStorm, and we are happily using it. I'm not sure for how long we would be happy with this. Maybe we get something else better than this, and we transform or we use that in the future. But for now, it's StackStorm. So first of all, what happened with SaltStack? So this was actually the data flow diagram for the auto remediation that we were doing using SaltStack. So what we used to do is we used to run a particular script on all of the servers using Salt Scheduler. So what Salt Scheduler is you can just compare it with cron in every 5 minutes or so, whatever time you tell him. So in every that time, it will run the script on all the servers. And in the script, you have mentioned to check all the applications that are running on that particular server. It checks all the application and find out which application is not working properly. And when it finds something which is not working properly, it sends a salt event from salt minion to salt master. So people who are not aware with salt stack, so salt stack works with a agent and master relationship. So agent, we call it salt minion, and every minion has a master. So yeah, so salt minion sends a salt event to salt master. Every event has a unique tag, so that salt master knows that or if he gets these kind of salt event, then what kind of reactor it has to run on salt minion. So according to the tag of the salt event, salt master recognize that okay, this is the problem, and this action we have to run. So those action could be orchestrator, complete workflow. It could be a simple salt state. It could be simple one-line commands. It could be a script, whatever. So so salt master eventually runs the script or command on the minion, and the problem is resolved. And if at any stage the workflow breaks, the data flow breaks, then we send notification to Slack. So this was the architecture that we were using with SaltStack. Now comes to the pros and cons of it. So first was if we talk about the pros, it was being used by all the different teams for configuration management, and we have said, as I have said, that we wanted to reduce the learning curve, so we used what everyone is already using. So this was a pro for us. Second, it has a very nice authentication and access management. It can integrate with your open LDAP setup, and you can create different groups on your LDAP, and you can just tell Salt Minion to allow only particular groups. Next was secret management. So as you are remediating problem on different apps, so sometimes you might need some credentials to access those apps or to restart those apps. So this the secret management is very easy with SaltStack. There are multiple modules written. So in Adobe, we use Vault for storing all the secrets. So there is a Vault module available in SaltStack, and it's very nice, simple to use. And for secret management, Salt also has something which is called Salt Pillars. So in Salt Pillars, you can store your credentials, and you can specify that which Salt minion can only access this credential and which cannot. Next one is easy to manage. It's completely based on Python, and if you want to write some workflows in SaltStack, it's YAML. So if you think Python and YAML, I guess these are the least these are the two programming languages which has the least learning curve. You can easily learn Python and YAML. So yeah, so you can write different modules of Python, and you can directly insert them into your Salt master. So it was easy to manage. Now talking about cons. It works fine with one product, two product, but we started sending data from multiple products. So there was some performance problems with this. So the performance problem was eventually because of the Salt event bus. So Salt event bus is the communication mechanism between Salt minion and Salt master. And when we send lots of parallel alerts from minion to master, then we have seen that lots of Salt event got missed and didn't reach to Salt master. So we are planning to explore Kafka, remove the Salt event bus and replace it with Kafka, but that is something which is going in progress, and there is no performance matrix we have it right now. Moving forward, one more thing was it's agent based. So if you want this setup, you need to install Salt minion on all of your servers. So there were lots of teams who are not very comfortable with this. So in Adobe, maybe we are standardizing SaltStack, but there were lots of teams which were already using some configuration management tool. Some were using Puppet, some were using Chef, and people were not happy to use two different configuration management tools on their servers, which was quite obvious. No chat op supports. So by chat op support, I mean if we, I mean in at least in Adobe, we spend a lot of time on Slack, talking to each other, and it would be very nice if we can run some commands or run some workflows or trigger something from Slack itself. So you can do it with SaltStack as well, but there is no inbuilt feature. You will have to manually install and configure a bot and integrate it with your SaltStack. So it's not provided by SaltStack, but you can do the workaround. Second was when we moved to Rundeck. So when we moved to Rundeck, so this was the data flow diagram. I guess it's little blur, but I'll explain it. So whenever there is a problem with any server, it goes to the notification router. So what notification router is, actually it's a rule engine which makes sure that when this problem comes, send the data to this particular ops tool. It could be PagerDuty, it could be Jira, it could be Slack, it could be anything. So it matches some strings, and based on the input string, it decides where it has to land. So yeah, so after notification router, if you have mentioned that it has to go to Rundeck for auto remediation, then it reaches to our Rundeck server. And in Rundeck server, we first check if it has crossed the threshold for flapping. So we have found that there were some problems which when we auto remediate, it resolved, but after 10 seconds, the problem comes back. So we have so to resolve this, we have make sure that there is a threshold that every alert has to match, and if it crosses that threshold, then we just send it back to the PagerDuty or something for human intervention. Second, one more flag it has to check, and that is connection failures, or it's or something is not able to auto remediate. I mean, your workflow is not working. So I mean, we don't want that alert to go and try again and again and stuck in the loop. So that's why this flag is there. So let's say if you have put the threshold of 3, so if the if your workflow fails 3 times, then it will reach to the on-call person directly. And yeah, after these 2 flags, if everything is good, then the auto remediation triggers and resolve your problem. Okay, coming back to again pros and cons of this architecture. The pro was Rundeck is very commonly used tool for deployments and self-service. So it provides a one-click automation, or one-click. You just do a click and it will run some scripts on some server and give you the output of it. So lots of teams were using it. They used to create a self-service tool to provide it to support team. So if they need something from engineering side, and which is a certain set of steps, then they can just click the button and they can do it by themselves. So these kind of self-service tools were being Rundeck were being used in these kind of self-service tools. So yeah, it was very common. Second, same thing, access management. It's very easy with Rundeck as well. You can connect with your Open LDAP. So this is the problem that we resolved, no agent installation. So Rundeck completely works on SSH model. So this was the problem with SaltStack, which we resolved in Rundeck. Moving forward, Rundeck has very rich plugins and integrations. If you go to the community for Rundeck, you will find almost plugins for all the available TechOps tools that people use, and the community is also very active. It has a very rich API. You can manipulate and you can control Rundeck using all parts and all features of the Rundeck using their APIs. So it was helpful if you want to trigger something, or if you want to run some commands programmatically. You can put the APIs in your code and it will trigger and it will resolve the problem. Good role-based access control. I won't say good; it's exceptional. I mean, this is the one thing that we very much loved about Rundeck. The role-based access control in Rundeck is very granular, and I mean it's very helpful. You can give only execute access to some group. You can only give write access to some group, and you can like this. You can segregate the role-based access control. HA is available, so you can install the Rundeck server in highly available. You can have multiple slaves, master, and all thing. So it's highly available as well. Active open source community. So open source community of Rundeck is very active. I mean, if you write something, you will get response very quickly. We have observed that. Coming to cons. So this was the biggest con that because of which we have to move to some other technology. Running complex workflows. So far we were running single executions and single commands, and if we want to imply some if else conditions in the workflows, then we have to write all the code in the script. But what Rundeck will do, it will just run the script. So everything you will have to manually write in the script. So it was very hard to manage if else condition using Rundeck, not in the script, using Rundeck. So that was the biggest con. It's completely Java based, so it might not be a con for everyone, as I've mentioned. So there are some people who prefer Python over Java. How many of you love Java, prefer Java over Python and YAML? Okay, lots of like-minded peoples again. So I'll prefer Python and YAML. Yeah, and chat op support, no chat op support. Obviously, I have said this. Now we come to Stackstorm based auto remediation, which we have currently in our production environments. So this is the architecture come data flow diagram. It might look a little complicated. I tried to make it less complicated, but I failed to do that. So in the lower box, it starts from the lower and goes to the top. So in the lower boxes, you can see these are the products. Some are in Azure, some are in data center, some may be on AWS or any other cloud. So all the notifications and everything we send to, everyone used to send to some operations tools. It could be Slack, it could be Grafana, it could be New Relic, it could be Jira. So we don't wanted to hamper anything which was already done by the engineers. We just wanted that, yes, it's good, you are sending all the data to these tools. We will collect all these data from these tools so that you don't have to do any changes on your side. So what we have done, we pull or they push, so Stackstorm provides both the model, to our Stackstorm environment, which is in Azure, and we have it in two different availability zones. So there are different microservices or functionalities we have set up on different servers for high availability. So every request which lands on Azure load balancer, it first goes to API and authentication service, where all the requests get authenticated, and after that it goes to RabbitMQ cluster. So everything is clustered here. So it goes to RabbitMQ cluster. So the backbone of Stackstorm is RabbitMQ, because all the communication has to go through that. And then from RabbitMQ cluster, all the requests go to the rule engine. So again, the concept of rule engine is to analyze the input data, and based on the input data that it's getting, evaluate what action it has to run. After analyzing what action it has to run, all the actions are stored in PostgreSQL cluster. So Stackstorm knows that which action it has to pick, and MongoDB cluster is used to push all the historic data which you can eventually use for reporting and dashboarding and everything, analyzing data. And so finally it gets what action it has to run, and then eventually go to your server and execute that particular action. Again, coming to the pros and cons. So there are some pros and cons with this one as well, but more pros and less cons so far. So the first pro is running complex workflow with multiple if-else condition is very easy in StackStorm. So this was the main reason I have said earlier that we plan to move ahead of Rundeck. So the complex workflow that in StackStorm you can write could be multiple if-else. You can take the output of your previous workflow and you can put it as an input in your next workflow. You can create your own decision tree. Uh, I'll give you one example of that. Let's say whenever there is a problem, there's a problem comes. For example, let's say you are using Solar, Apache Solar or anything. So you know that whenever a collection fails, there could be multiple reasons for it. You have seen it with your experience that sometimes disk fails, then my Apache Solar doesn't work. Sometimes there is memory issue, that's why it doesn't work. Sometime there is a lots of concurrent hits that you are getting that your server is not able to handle, and that's why it fails. So what you can do is you can put all those scenarios what you have experienced in past in a parallel execution. So whenever there is a problem, it execute or it checks all those possible issues that you have seen in past, and checks which one is currently happening and resolve that problem. So it takes very less time because all the execution happens in parallel. You can put 10 different scenarios, you can put 50 different scenarios. So that saves a lots of time. So yeah, and basically string matching, as you can say that one workflow gives some output, and based on the output you take next decisions. If the output is something else, do something, and if something else, then do something. Second thing, easy to integrate with other monitoring and automation tools. So it provides, so StackStorm basically provides a lot of plugins. And I mean, I haven't seen any TechOps tool for which there is not a plugin available there. So there are easy plugins available on the community as well as provided by the StackStorm. Chat op support. So this is something which is that we get in StackStorm. So you can just log into Slack and you can write some commands and it will execute on your server. So it helps when you are driving or you are not in front of computer or you don't want to log into computer, then you can just type it on mobile and your problem is resolved. Highly available, as I have said, it's based on microservices infrastructure, so you can put different services in different availability zone and different servers. You can separately put all your DBs and you can cluster them. So highly available. Again based on Python and YAML, so easy to understand, easy to configure. And same thing as Rundeck, it has very rich APIs and you can control each and every feature of a StackStorm programmatically, which is important if you want to trigger anything from your code itself. One more functionality, it provides both listening and polling. So you can either push your alerts to StackStorm environment, or StackStorm environment can keep polling and keep listening from the different TechOps tools for alerts. So it's both push and pull model. Can be clustered to provide HA, highly scalable. Active open source community. So with StackStorm as well, the community is very active. So there are lots of people who have joined the community, and there are some StackStorm people also available in the community all the time. So you get a quick response on any of the problem. The cons, we have found only one con so far. I don't know if it counts as a con, but the role-based access control in StackStorm is provided only in the paid version. So if you want it in the open source version, then probably you will have to write your own, that we are doing currently. So this was our journey. Started with SaltStack, moved to Rundeck, then moved to StackStorm. So so far I have talked about resolving the problems, and auto remediating everything. But let's now talk about analyzing the data that we are generating or we are getting. So if there are lots of problems which are being resolved, so you can eventually analyze the data of all your auto remediations that you are doing, and you can find if you look at the graph or if you look at the chart, you can easily find what is the pain point in your architecture. This is one of the graph uh, which says that how many auto remediation has been run on different servers. So I'll ask you, which server is having problem? So what's the pain point of my architecture? Yeah, which has 218 counts. So there are 218 times auto remediation has ran on that particular server, and if you compare it with different servers, so they are very less. That means there is something wrong with that server, and there is something getting failed again and again. So yes, this is the pain point of your architecture. Moving forward, so this is one more graph where yep, that's better. Thank you. Yeah, so this is one more graph where we have put, instead of putting the host names, we have put the services for which we were running auto remediation. And if you look at the top right chart, so you can easily find out that which service is having problem. So same rescue service, because this service is getting failed again and again, and we are running lots of auto remediation for this one. So there is probably something in the back end which is going wrong, and we should go and find the root cause and fix it. But for the time being, we have the auto remediation so that there is no customer impact. uh, Different minds, different thoughts. We initially put this service thinking about auto remediation, resolving some problems and everything, and we showed it to all the different teams in Adobe. And when we started talking about it, people have different thoughts. I mean, they do not wanted to use it only for auto remediation. They have different things in their mind. First of all, if I talk about, people say, why not use it for auto scaling? I mean, you might be thinking that, let's take an example of AWS. AWS provides auto scaling. What is special it will do? So if you think about, so how many of you have used auto scaling in AWS? Yep. So if you have used, you might be aware that they provide auto scaling, but based on very static numbers. You can just say that if CPU goes above 80%, then add these number of servers. If RAM goes above this, then add these many things. But are all the problems related with system side or server side? There could be problems because your application is getting failed, not your server. For example, you have created a service to handle, let's say, 100 requests at a time, but suddenly it has 1,000 requests. Your server will fail, but AWS won't auto scale it because your RAM may be working fine, your CPU may be working fine. It's just your application malfunctioning. So in this, so Stackstorm basically it's a event-driven automation. So that event could be anything. That event could be the percentage of CPU being used, or how many number of requests you are getting on your application. So you write some scripts which checks after 5 minutes or so that how many requests are coming, and if the request is let's say if the request is more than 1,000, then add 10 more servers in the auto scaling. But suddenly if the request goes to 120 or 150, then add 15 more. So these kind of dynamic change you can do in the auto scaling if you use a event driven automation. Second thing, people say, why not use it as a scheduler? So it's same thing. If you want to run a particular, let's say, test environment, you have test environments, you run some tests periodically. So you can use this as a scheduler as well. Let's say, I mean, in every 5 minute or twice in one day, run these kind of actions. So it can be used as a scheduler as well. Then some people say that why not use it as a connector between two microservices. So there were some teams who have written some microservices, and eventually there comes up another microservices from a different team, and they want to they want to have a communication between two different microservices, and to have communication across firewall, they have to write one more application, one more microservice which can provide which can act as a bridge between both of them. And when we presented this to those team, they said, why do we need to write all the code? I mean, you can do it. We can trigger some event saying that we need to send this data from this microservice to that microservice, and we can use that bridge. We can use your application as a bridge for that. So this is again a different mindset. Some people say, why not use its data for correlation, anomaly detection, and machine learning? So these are three different things. First, I would say correlation. So correlation could be smallest example is, let's say there is a load balancer, and there are 10 different services who will be impacted if the load balancer goes down. So with the data that we are collecting, how many auto remediations we are running, in future, if we analyze the data, then we can find out that if there is an alert on this load balancer, then probably in next couple of minutes, all the services will go down, and we'll have a problem on all these services as well. So this is how we can find the correlation between different things, and we do not need to run auto remediation on all of them, and we can predict what's going to happen in couple of minutes or so if the service goes down. Anomaly detection, you can collect the data, and you can analyze the data for anomaly detection. By anomaly detection, I mean again, with simplest example, let's say disk space. So disk space can be filled in 1 minute, or in 1 hour, or in 7 days. So you do not know when it's going to fill. I mean, right now, let's say it's 20%, but there is some application which is malfunctioning, and you are getting lots of logs. So it won't take more than 30 minutes to fill up all the remaining disk space. So that's an anomaly that usually don't happen. So these kind of things we can find out using by analyzing the data. And of course, machine learning, there is lots of data which we are using for reporting and analyzing. And if you analyze those all data, you can easily find out, or you can predict some of the alerts which can eventually come if by analyzing the previous data. Good part. The achievements that we have done after implementing this. First was 70% of our alerts now get resolved using auto remediation. So after implementing this, we found that there is approximately 70% of the alerts which has a certain set of commands that it has to run to resolve the problems. We put all of them in auto remediation, and now approximately 70% alerts get resolved by auto remediation without any human intervention. Reduced customer service outage, we call it CSO, approximately by 40%. So this is the data that we get from the management, and I'm publishing it here. So this is my experience. Now we are able to save approximately 4 hours every day of a SRE person, and that time a person can use it to automate something else, to learn what he wants, maybe to hear some songs, play games, whatever he likes. So we are saving at least 4 hours of the SRE person when he's on call. Reduced mean time to resolve, as I have explained it earlier as well, that if a human has to resolve a problem, then it takes time to get into the server and resolve the problem. Instead, the machine is doing it by themselves. Okay, lastly, the conclusion out of all this. First, auto remediation saves a lot of time and help you to have a good night's sleep, which is very important and self-explanatory. Moving forward, look at the bigger picture and understand what fits you the most. With conclusion, I would say this is also an advice from my side, because the mistake that we have done was to not look at the big picture. We started with very small thing and later on realized that, oh no, I mean, we have some other workflows as well, and we might get some different workflows to run, and then we switched our infrastructure, switched our architecture. But I will advise to look at the bigger picture in the starting and build something for future, not for today only. This is very important point, and I'd like to explain it. Don't celebrate adding more auto remediation workflows. You have to celebrate removing them, because auto remediation is a band-aid that you are doing on production so that customer don't see the problem. But if an auto remediation is triggering, that means there is something wrong in your code base, and you have to loop those loop those feedbacks, uh, all the data that you are getting back to SRE team or DevOps team, saying that we are resolving it for right now, but there is something wrong in the code that you have to fix, so that we don't have to actually run it. So currently we are running auto remediation, but we are not very happy to do so because it's just a bandage. And that is all I had. Questions?